Hello, I'm back this time with a question from section 15.5, question number 12, which asks to find the surface area of the sphere, part of the sphere, given by this equation, x squared plus y squared plus z squared equals to 4z, that lies inside this paraboloid given by this equation. So very quick review for the surface area. If a surface is given by a function like this, a function with two variables f, x, y, then the surface area of the part of the surface lying on about the region B, is given by this double integral. So you find fx squared, find fy squared plus 1 dA. You find that function, that's a function with two variables, evaluate that double integral. So in this case, what is my function? The function, there is an equation given here. So it is x squared plus y squared plus z squared equals to 4z. First you may say, okay, what kind of a sphere is this? Okay, to see that I have to do some algebra. So I bring 4z to the left hand side, so minus 4z. Then I want to have this a complete square for this term. So to do that, I add 4 to the left hand side of the equation, and another 4 to the right hand side of the equation. Okay? So basically I haven't changed the equation, but I prepared everything so that I can now write x squared plus y squared plus this whole thing here, z minus 2 squared equals to 4. So this is a sphere of radius 2, 4 square, 2 squared is 4. Center that 0, 0, 2. So that's the part. Now I can go ahead and find that function using that. So I'm just going to consider upper hemisphere of this sphere. So I have I can write this as z minus 2 squared equals to 4 minus x squared minus y squared. Then find the square root of both sides. I'm just going to do upper, that means I consider the positive part, and then you add plus to both sides, so z is going to be 2 plus 4 minus x squared minus y squared, and that's my function. That's my function, f x y. Okay? Now I have to find this thing. So what is f(x)? I have to find that first. So I have a square, and then the derivative of function, square function is derivative of inside over 2 times square root of the function. So 4 minus x squared minus y squared. That's my f(x). Fy is the same thing. So differentiation rule for square root, you can use chain rule for and power rule together. You get that. So it's 4 minus x squared minus y squared. Okay, everything is ready to find the integrand. So the integrand, which is equal to f of x squared plus f of y squared plus 1, is this guy squared. So let me just cancel those 2 and those 2's. Then square of negative x is x squared over square of square root is what we have inside. square root plus this squared, which gives me y squared over 4 minus x squared minus y squared plus 1. Okay, so you write this, find common denominator. You will have x squared plus y squared plus this guy. So in the numerator, I'm going to have 4 only. And in the denominator, 4 minus x squared minus y squared. So that's my integral. So now I have the integrand, and I need to find the region. What is the region? So it is the region which lies in this paraboloid. So I can draw you some pictures here. So it is a sphere of radius 2 centered at 0, 0, 2. If this is 0, 0, 2, that's there. Make it three-dimensional. That's the sphere we have. But what about the other one? The other one, I mean the one that determines the curve, it is given by it is paraboloid of that form. So we have and the part that we are trying to find its surface is this part. So I have to. That's the part. Okay. Now you say, what is the region on which I have to take the integral? So the region is the shadow of this part of the surface, which is exactly where these two guys intersect, the paraboloid and sphere intersect, and then anything between. So basically, if you find the intersection, it is going to be circle, but everything inside that. So that's my region. Then I have to intersect these two and find. Okay, then I have to find the intersection of this sphere and paraboloid. So the equations are given here, x squared plus y squared, and also this guy, x squared plus y squared plus z squared equals to 4z. So intersection of this guy. You can see you have to combine these two equations and come up with some solid equation in terms of just x and y. The easy way to do that is that you see that x squared plus y squared, which appears here, with that paraboloid is equal to z. So I can rewrite these two equations as z plus z squared equals to 4z. And simplify z squared equals to 3z, which gives me z is equal to 0 or z equals to 3. You can see it here, actually. They intersect at origin when z is 0, and they intersect at the level z equal to 3. Yes? So now z equal to 0 is the part I don't care, but this part, z equal to 3, is the one which gives us this circle here. Okay? So just put 3 either there or here. So basically the region is going to be, so the intersection is 3, z is 3, x squared plus y squared. It is equation for a circle centered at origin with radius equal to root 3. So this guy here is given by that, but I want to find inside that. So my region is going to be all x, y's such that x squared plus y squared less than 3. Okay, I found the region, and now I can integrate. Let me erase some parts from here. And now surface area which is given by this 4 over 4 minus x squared minus y squared dA. The region is that circular part. Okay, this is something that we have to remember always, that when you have circular region, the nicer coordinates would be polar coordinates to integrating. So, in other words, the best idea would be I rewrite this region in polar coordinates, which it is a circle. So basically r is between 0 to √3, and it's the whole circle, so that means theta goes from 0 to 2 pi. Everything is ready to go. 3 steps to write an integral in terms of polar coordinate. Write the boundaries, change your equations, change your variables in integrand to r and theta. So if I do, this is 4 minus, this is r squared cosine squared plus r squared sine squared, so it gives me this. And then I have the third step is dA for polar coordinates. Okay, so it is ready to go. I can start from here and go ahead. So I have 0 to 2 pi. I have to integrate what I have inside this integral. So how can I integrate this guy? Here I have inside the integral it is 2. Sorry, let me simplify this and then you will see how to integrate that. So the square root of 4 is 2. I have in numerator, I have that. In the denominator, I have this guy here. And then I have r here, dr d theta. Probably this would make easier to see that I have to use substitution to evaluate this integral. So u is 4 minus r squared, and then du is going to be minus 2r dr. Okay, that is good sign, because I have 2r dr there, so I can rewrite this as du. D theta is there, I'm not touching that. So there's nothing else in the numerator. In the denominator is u. Okay, what about the boundaries? So if r is 0, then u is going to be 4. If r is equal to √3, it is going to be √3 squared, which is 3. 4 minus 3 is going to be 1. So the lower one goes to lower one, upper one goes to upper one. Okay, can raise here now. Okay, now I have this integral to evaluate 0 to 2 pi. You guys can easily see that this is u to the power negative half. Use power rule for integration and you will get 1 over negative half plus 1, u to the power negative half plus 1, go from 4 to 1. Oh, I made a mistake, small mistake. Here you see I forgot this negative, small negative sign. I had 2r dr in my integral. I didn't have this minus. I can put that minus somewhere here. Okay, so basically I will have this here, then d theta. Then you go from, this would give us, this is half negative 2 u root u. And go from 4 to 1. Fundamental theorem of calculus says that this is negative root 2 1 minus 2 root 4 d theta. And then this is 0 to 2 pi. Negative 2, this is a 4. Negative 2 plus 4, this is 2 d theta. Yes, 2 d theta, integrate is 2 theta, 0 to 2 pi, and this is equality. And then you get 2 times 2 pi minus 2 times 0, which gives me 4 pi. Okay. Thank you for watching video. That was question 12 from section 15.5.